Have you ever gazed up at the night sky and wondered, where did all of this come from? It's a question that has echoed through the ages, a timeless curiosity that has sparked countless quests for knowledge. Throughout history, humanity has sought to unravel the mysteries of our universe's origins, from ancient philosophers gazing at the heavens to modern-day scientists probing the fabric of reality. This pursuit has been a constant thread in our collective story. Today, the most widely accepted explanation for the universe's inception is the Big Bang Theory. It's a theory that has transformed our understanding of the cosmos, offering a glimpse into the very birth of reality as we know it. But, as we'll soon discover, even the most comprehensive theories have their limitations. So let's dive into the Big Bang Theory, which suggests that all we see, from the smallest particle to the vastness of space, began from a singular point. Imagine everything you know, all matter, all energy, compressed into an infinitesimally tiny point. This is the starting point of the Big Bang Theory. Now let's break it down. The Big Bang Theory is a cosmological model that depicts the birth of the universe. The theory doesn't suggest that there was an explosion in space, rather it posits that space itself began from a singular point and expanded. We can liken it to a balloon being inflated. Initially, the balloon is tiny and all the points on its surface are close together, but as it inflates, those points move further apart. Similarly, in the Big Bang model, all matter and energy started from a singular point and over time expanded into the universe we know today. Now let's add a bit more complexity. The Big Bang Theory also suggests that not only did the universe originate from this singular point, but so did time and space. Imagine that, a universe without space or time is quite an abstract concept, isn't it? But that's one of the fascinating ideas that the Big Bang Theory introduces. As this initial singularity expanded, it created space and time, and the energy within it cooled and condensed into particles. These particles eventually formed atoms, which in turn clumped together to form stars and galaxies. It's like a cosmic recipe, starting from a simple ingredient, energy, and ending with a complex and diverse universe full of galaxies, stars, planets, and life as we know it. In essence, the Big Bang Theory suggests that our universe is continuously expanding from this initial explosion of energy. But remember, this is just a theory. Despite the compelling evidence that supports it, there are still many unanswered questions and mysteries. As with all scientific theories, our understanding of the universe and its origins is ever evolving. So, stay curious and keep exploring. Who knows what we might discover next? But how do we know this? What evidence supports such a grandiose theory? Let's dive right into it. The first piece of evidence we'll discuss is the redshift of galaxies. Redshift is a phenomenon where light or other electromagnetic radiation from an object increases in wavelength or shifts to the red end of the spectrum. This shift is an indication that the object is moving away from us. In the 1920s, Edwin Hubble discovered that galaxies are indeed moving away from us and that the universe is expanding. This discovery is consistent with the Big Bang Theory, which posits that the universe started from a single point and has been expanding ever since. Our second piece of evidence is the abundance of light elements. The Big Bang Theory suggests that in the early universe there was a hot, dense state where protons and neutrons combined to form the nuclei of the lightest elements, hydrogen and helium. As the universe cooled, these reactions ceased, leaving us with a specific ratio of hydrogen to helium. When we look up at the stars today, we see this exact ratio, which further supports the Big Bang Theory. Lastly, we have the cosmic microwave background radiation, or CMBR. This is the afterglow of the Big Bang, a faint echo of light that permeates the universe. Discovered by accident in the 1960s, the CMBR is remarkably uniform, suggesting that the early universe was homogeneous, just as the Big Bang Theory predicts. These pieces of evidence, the redshift of galaxies, the abundance of light elements, and the cosmic microwave background radiation, all point to the same conclusion. The universe had a beginning, and it's been expanding ever since. However, it's important to remember that in science, evidence supports theories, but it doesn't prove them beyond a shadow of doubt. These observations provide compelling evidence for the Big Bang Theory, but they don't prove it conclusively. Science is a process of continuous discovery, and our understanding of the universe is continually evolving. Yet it's important to remember that our current understanding is not the end-all be-all. The Big Bang Theory, a cornerstone of cosmology, is a testament to this evolving understanding. The Big Bang Theory, while it provides a plausible explanation for the birth and evolution of the universe, doesn't have all the answers. It leaves certain questions unanswered, which in turn open up vast realms of mystery and speculation. For instance, the theory doesn't explain what caused the Big Bang itself. What was there before it? In the realm of the Big Bang, these are enigmas yet to be unraveled. Enter dark matter and dark energy, two enigmatic entities that challenge our current understanding of the universe. Dark matter, an invisible substance, is believed to make up about 85% of the universe's matter. Despite its prevalence, we have yet to detect it directly. It's like a phantom, only making its presence known through its gravitational influence on visible matter. But there's more. Dark energy, an even more mysterious force, is believed to be driving the accelerated expansion of the universe. It's like a ghostly gas pedal, pushing galaxies apart at an ever-increasing speed. The Big Bang Theory, as it stands, struggles to adequately explain these dark entities, leaving us in a cosmic twilight of understanding. As we push the boundaries of our knowledge, we stumble upon more questions than answers. This is not a shortcoming, but rather the beauty of scientific exploration. It's a reminder that our understanding of the universe is a work in progress, a constantly shifting mosaic of theories and observations. So, while the Big Bang Theory provides a compelling narrative for the universe's origins, it's not without its limitations. It's a piece of the puzzle, but the full picture is far more complex and intricate than we can currently comprehend. Our understanding of the universe is far from complete, and the Big Bang Theory, while widely accepted, is not without its critics and controversies. So could we be wrong about the Big Bang Theory? Well, the simple answer is yes, we could be wrong, and that's not a shortcoming, but rather the beauty of science. Science isn't a collection of infallible truths, but a process. It's a relentless pursuit of understanding, a never-ending journey of questioning, testing, and learning. Theories are not sacrosanct in science. They're not unassailable truths, but our best understanding of the world, given the evidence available to us at the time. And the Big Bang Theory is no different. It's a model of the universe's history, based on a multitude of observations, but like any theory, it's open to revision, improvement, even complete overturning if new evidence demands it. So when we say that we could be wrong about the Big Bang Theory, what we're really saying is that our understanding of the universe is not yet complete. There may be phenomena we haven't observed, laws of physics we haven't discovered, dimensions of existence we haven't even dreamt of, and any of these could change our understanding of the universe's origins. But here's the thing, being wrong is not a failure in science. It's an opportunity to learn, to grow, to inch closer to the truth. Every time a theory is revised or replaced, we gain a deeper understanding of the universe. We learn more about the cosmos and our place within it. In the grand scheme of things, we're just a tiny speck in a vast, complex universe. Our knowledge, as vast as it may seem, is but a drop in the cosmic ocean. But every drop counts. Every piece of knowledge, every theory, every discovery is a step towards understanding the grand tapestry of existence. In the pursuit of understanding, we must always be ready to question our assumptions and embrace the possibility of being wrong. Because that's how we learn, that's how we grow, and that, in essence, is what science is all about. In the end, the Big Bang Theory is our best understanding of the universe's origins. But it's not the final answer. We've journeyed through the simplified explanation of the Big Bang Theory and examined the remarkable evidence that supports it. From cosmic microwave background radiation to the distribution of galaxies, the signs point towards a singular explosive beginning. Yet we've also acknowledged the limitations of our understanding. The Big Bang Theory is a product of current scientific knowledge and is subject to change as we uncover new information. We've pondered the possibility that we could be wrong. After all, science is a process of constant refining and redefining. As we venture further into the cosmos, new discoveries may challenge our current theories, and that's the beauty of it. Science is a never-ending quest for knowledge, and our understanding of the universe's origins is just beginning to unfold.